Now we look at a sequence a sub n is equal to 1 minus n over 2 plus n. Spoiler alert, it converges, but we're going to find that by doing something different than we have so far. Our instructions are determine if the sequence is increasing, decreasing, or not monotonic, and is the sequence bounded. And here we have a new word, monotonic. Monotonic means always increasing or always decreasing. As part of our exploration, let's write out a few terms of this sequence. If n is equal to 1, our first term, it's going to be 0. If n is equal to 2, we get the value of 1/4. Whoops, I put the comma in the wrong place. If n is equal to 3, we have a value of negative 2/5. If n is equal to 4, we have the value of negative 3/6. That reduces to 1/2, but I'd rather see the pattern here. If n is equal to 5, then our value is equal to negative 4/7. Now as we look at these numbers, of course the numerator is increasing by 1 each time, the denominator is increasing by 1 each time, and after the first term they're all negative. If we think about decimal values though, 1/4 is 0.25, 2/5 is 0.4, 3/6 is 0.5, 4/7 in magnitude is bigger than 1/2. So these are becoming more negative as we go. I'm also going to make a note here that a sub n is less than or equal to 0. Now, as it looks like these terms are getting more negative, we suspect that these terms are getting smaller. In other words, I suspect that the sequence is monotonic decreasing. Another way to write that the terms might be getting smaller is to say we think that a sub n plus 1 is less than a sub n. Using the definition of our sequence, a sub n plus 1 would be 1 minus the quantity of n plus 1 divided by 2 plus the quantity of n plus 1. And we suspect that that is smaller than 1 minus n over 2 plus n, but that's really kind of difficult to show. What we're going to do is we're going to make a series of if and only if statements. What we just wrote down, that inequality, is true if and only if. Now, by simplifying the fraction on the left, I don't mean reducing, I mean 1 minus the quantity of n plus 1. Well, the 1's subtract out, right? And then 2 plus n plus 1, we collect like terms, is what I'm getting at. By doing that and then cross multiplying, because our n's are positive, our denominators are positive, and so we can cross multiply over the inequality without any problems, we end up with negative n times the quantity of n plus 2 is less than 1 minus n times n plus 3. Now, this is a one-way implication, really, right? What we started with leads us to what we just wrote down. But it's also true that if the second inequality that we just wrote is true, then the first inequality will hold true. So the if and only if actually applies, though I'm thinking of this as basically a series of implications, but I have a goal here. Now, simplifying each side of this inequality, we get negative 2n minus n squared is less than negative n squared minus 2n plus 3. And this is true if and only if. Now I can subtract out the common terms on both sides, or in this case add. I have negative 2n on both sides, that goes away, negative n squared on both sides, and I'm left with 0 is less than 3. What we have is a true statement. Now this true statement with this series of if and only ifs means that since 0 is less than 3, we do have that a sub n plus 1 is less than a sub n, which means that a sub n is decreasing as we expected. We were asked for a couple of things though. We wanted to know, is it increasing, decreasing, or not monotonic? And then we want to know if it's bounded. In other words, let's look at a limit. It's the limit as n approaches infinity of 1 minus n over 2 plus n. I'm going to handle this by dividing out the largest power of n that appears in the denominator. So this is equal to the limit as n approaches infinity of 1 over n minus 1 divided by 2 over n plus 1. The terms with n in the denominator go to 0 as n approaches infinity, and this limit is equal to -1. all the terms that we wrote down before are between 0 and -1, and then the limit is -1, we've therefore been able to show that a sub n is between -1 and 0. And I've written this as inclusive at 0 because the first term was 0. Since this inequality holds true, we have a sub n between two numbers, -1 and 0. The sequence a sub n is bounded. It is contained between two numbers. Now that does it for this exercise, but this leads us to conditions of a theorem known as the monotonic sequence theorem. It's a lot of big words, heavy stuff. It says every bounded monotonic sequence is convergent. And we aren't going to prove this theorem here, but we're sure going to use it a lot during this chapter.